This is a demonstration of amphoteric metal ions. There's only a few metals that, when they become ions, exhibit amphoteric properties, the ability to act as an acid or a base, or be affected by an acid and or a base. And they include lead plus 2, aluminum plus 3, chromium plus 3, and zinc plus 2. And what they do is, because they're so small and their electron density is so great, what they tend to do is they tend to draw in electrons and make complex ions. Before we get started, I'm going to show you what I'm talking about. I'm going to take some aluminum nitrate. And this chemical, I'm essentially making some free aluminum ions. So I'm going to take some aluminum nitrate and dissolve it first in this beaker. So I'm going to drop in aluminum nitrate. And as you know, if the solubility of nitrates are very high, nitrates, you're stretching a -1/4 atoms. So this is going to dissolve very readily. Let's get a little bit more to increase the concentration. All right, and as you can see, it's dissolving very readily, as most nitrates do. Okay, and it's still doing its thing, and metal, little stirring, magnetic stirring rod is stirring away. Now, what's happening here, and let me show you, is I have aluminum nitrate, and in water it breaks apart into aluminum plus 3, and of course the nitrate ion, which is a spectator ion here. Now, what happens is, because this ion, like most amphoteric ions, is so small, it draws in 6 waters. They're so attracted to it. So the aluminum ion draws in 6 waters, and it becomes something called a Lewis acid, because it draws in the electron pair somewhat into very close to the ion. And what it does is it causes an electron drift from the hydrogen to the oxygen, and what can happen is H's can be sloughed off. And therefore, this is an acidic solution now. But because we have 6 waters who are now surrounding it, what we would say an octahedral complex. Why? Well, 6 waters will find what we would say a very stable octahedral position here. So what we have is a complex. We have aluminum with 6 waters, water molecules surrounding it, and the whole complex is still plus 3, because we have a plus 3 and 6 neutral molecules. Now, what I'm going to do from this position is I'm going to add some hydroxides. And a hydroxide will be able to, a strong base anyway, this hydroxide will pull an H off one of the waters where the electrons are being a little bit electron deficient because of the drift, because these electron pairs in between the H and the O is drawn to the aluminum. So a base can yank off these H's one by one, and that's what's happening. So this aluminum water complex loses an H. Notice it becomes aluminum H2O5. It was H2O6, and makes a hydroxide. And notice the charge goes to plus 2. So by adding a base, I'm yanking an H away from the water. And now it becomes OH. And as I add some more base, it becomes OH2. Notice the charge goes from plus 2 to plus 1, because we have 2 hydroxides now as I yank what? The H's away from these hydrogens that are susceptible because of the drift of electrons between the O and the H. Now, so as I pull H's off, we go from 6 waters surrounding to 5 in a hydroxide. We do it some more. We have 4 and 2 hydroxides, and we do it one more, and we become 3 hydroxides and 3 waters. Now, there's something special that happens here. Look at the charge. It goes from plus 3 to plus 2 to plus 1. And then one more, it goes to 0. And this is special. When this complex goes to 0, water cannot dissolve it anymore. And it's a solid, it's a precipitate. So as I add base to this, we should see a precipitate occurring. We'll stop there and let's do it. Okay, so let's drop some base. And watch as we pull the H's away from the water molecules surrounding it, we should get, and I'm using a pretty strong solution here. And you can see that I've got some clouding going on, so my strong base yanked enough of those H's, and I've created a precipitate. Okay, so there is a cloudy precipitate, and that precipitate, again, is this complex. It's 0. We pulled off 3 of these. Now, why is it 0, and why is it a precipitate? Because water has nothing to attract it. when it was charged, along the way, it dissolved because water could attract it and break it down into particles. But now, water can't do anything with this. It's no charge, so it's a precipitate. Now, it's a weak base, it's an insoluble base, but with a strong acid, like magnesium hydroxide, which is usually insoluble. Okay, so with a strong acid, I could try to dissolve this. All right, I should be able to add some acid. As you can see, it should dissolve it. Now, why did it get dissolved? We're getting a little clearer. Well, because very simply, from this precipitate here, adding H pluses, I'm able to what? Reprotonate those water molecules and now make it into a charged compound. And once it's charged, the water can attract it and dissolve it. All right, so I'm going back that way. But that's still not what proves amphoteric properties, because most things that are hydroxides, whether they're insoluble or not, are going to be affected by a strong acid. Okay, so let's add some more base, and let's recreate the scenario where I'm going to have some zero charged. Okay, now I had some acid probably left over. Okay, not enough. Added too much acid. And I'm still getting there. All right, there I'm back. Now, where do we talk about why is it amphoteric? Here we go, party people. Why is it amphoteric? Well, when I have my soluble precipitate right here, insoluble precipitate, here's the cool thing. If I add more hydroxides, I could yank off another H off of my complex ion and make it what? -1. By pulling one more, notice H2O3, this becomes H2O2. And by yanking one more what? H off, I make what? 4 hydroxides. And where it was once 0 is now -1. So I can add more what? I can add more base to this to make it dissolve. And that's where it's amphoteric. It can be affected by what? A base, right? If this is pulling off an H, it's acting as an acid here, right? This one is doing what? Donating a proton to the hydroxide and acting as an acid. So this can act as an acid in the presence of the hydroxide. It can act as a base, right, in the presence of an H+. This is what makes it amphoteric. So if you can take this insoluble compound and add more base to dissolve it, then you have an amphoteric ion. Most things will go back with acids. They will, but going forward. So we're going to add more base to dissolve it. That's what makes it amphoteric. So here it comes.